Introducing Sophia.
Thank you. Thanks. Oh, thanks, guys. All right. Welcome. Good afternoon, and welcome to my senior project. Is it just me, or is it getting hot in here? I'll give you a hint. It's not just me. Here's the thing. I have to prove my thesis, talk for 20 to 22 and a half minutes, and I have to do the things on your rubrics. And if I don't, these two are going to hold me trapped here forever. I want to graduate, okay? Right, positive vibes. This is my thesis. The climate is changing, and greenhouse gases are the main contributor. Humans are contributing significantly to climate change because humans are disrupting the carbon cycle, and there are ways to mitigate the effects of climate change because climate change's worst effects can be avoided through a combination of reducing greenhouse gas emissions and carbon sequestration. Let's get into it.
What is climate change?
Wow, you guys are a great audience. Okay, well, first we have to address the question of what is climate. So basically, climate is what you expect, weather is what you get. Weather is like whatever you choose to wear in the morning, like for the day, and climate is what is in your closet, like what you'll need to wear during the year in that area. The National Oceanic and Atmospheric Association describes climate normals as averages of temperature and rainfall and humidity over 30-year periods. So climate change those climate normals have been changing significantly over the past century.
So is the climate changing?
Gosh, you guys are so on track. Thanks. Yes, it is. Here is a graph which shows the temperature change since around the time of the Industrial Revolution. I know it's not exactly Ms. Gibson, but you get it. Up into about 2015, you can see it's going up significantly. And really, I feel like everyone here has seen the news stories. The climate is changing, like natural events, storms and things. Yes?
Yes.
Okay, I'm seeing lots of nods. Good job. Yes!
Yes.
Bam! First point proven. It's going to be great. Okay. So how does climate change? There's a few different contributors. There are predictable small shifts in Earth's orbit. That'll come on in a second. The scientists predict that the Earth in 30,000 years is going to move far enough away from the sun to go into another ice age. We don't really need to worry about that for a while. The orbit has been pretty steady for, the century. It's been good. There's also solar activity. Some people blame climate change on solar flares or something, but again, the sun's been chilling out pretty much, just shining on, constant. Some people talk about tectonic activity or volcanic activity, but volcanic activity really hasn't put that much heat into the atmosphere compared with the last contributor, which is varying amounts of greenhouse gases. We're going to move on. Okay. The greenhouse gas effect. I have this, but I'm also going to draw a little diagram, all right? Got the Earth, you've got the sun. Clouds on Earth send back into space about 20% of the sun's energy that reaches Earth. A lot of the sun's energy, though, is trapped by other clouds and greenhouse gases such as carbon dioxide and methane, and water vapor. So yeah, the sun's rays hit Earth, and then they bounce back at a different wavelength, and they're blocked by a cloud. We get it. Without the greenhouse gas effect or without an atmosphere, Earth would be literally frozen. Just a solid frozen rock hanging around in space. Carbon dioxide is the most important greenhouse gas because it determines how much water vapor is in the air because it remains out of gas for a longer time. And as we can see here, carbon dioxide levels are higher than they have been for thousands of years. And I'll get to how we know that. That's coming, I promise. But basically, the current level of carbon dioxide is over 400 parts per million in the atmosphere. And for most of the past 800,000 years, it's been 300 parts per million or below. So, climate's changing, and greenhouse gases are the main contributor. Bam. Believe it. The carbon cycle. I'm going to draw some more diagrams to explain the carbon cycle. There are two parts of the carbon cycle. The short carbon cycle is basically just, wow, that's a really bad plant. It's photosynthesis, right? There's carbon dioxide in the air is absorbed into the plant and it emits oxygen, and then the plant dies. That's supposed to be fire. It's eaten by animals, or it's burned, or it just dies, and it releases CO2 back into the atmosphere. The long carbon cycle takes like thousands or millions of years, all right? So, got the ocean. The CO2 in the air interacts with the water, and it creates carbonic acid. That's why the ocean is slightly acidic. It's not just like pH neutral. Phytoplankton, this, in the water, I'm an artist, taken the CO2, and because like phytoplankton, they also photosynthesize, and also plants in the ocean, taking CO2, and then they die, and they go to the bottom of the ocean, and they sit around in the muck, and for ages and ages and ages, the crushing pressure of the ocean weighs down upon it, and it becomes sedimentary rock, and maybe eventually it becomes oil and coal, and then maybe that rock emerges thousands of years later, and the rain weathers it away until that carbon can enter the short carbon cycle again. But basically, carbon in the long carbon cycle just stays underground for ages. That's the carbon cycle, all right? The carbon cycle is changing because humans are interfering more than ever before with it by burning oil and coal and natural gas and things. So we're taking carbon that was in the long carbon cycle, that's not how you spell coal, and we're putting it into the short carbon cycle. So when there was a relatively even amount of carbon in the short carbon cycle and the long carbon cycle, but the scale is tipping. There's more in the short carbon cycle. So basically, carbon sinks, which are just things that take carbon out of the atmosphere, like plants in the ocean, are absorbing more carbon than before. So the ocean is actually becoming more acidic. That's science, baby. Also, here we see a correlation between the, you know what, I have a pointer here. Thanks, Ms. Gibson. I have a correlation between the amount of carbon dioxide in the air and the Antarctic temperature over 800,000 of years. Now I hear you saying,
how do we know what the climate and atmosphere were like thousands of years ago?
Kyle, I don't hear you saying the questions. Here's how we know. Ice cores, mostly. There are a few different things that scientists or paleoclimatologists, those are people who study the ancient climate, can use to study what the climate was like thousands of years ago. They can use sedimentary rock and they can use petrified trees, but mostly they use ice cores, which is really cool. This is like a cross-section of an ice core. I've already used all this before, so we're going to move over here for a diagram of how ice cores are created. It snows in the Arctic and Antarctic. Here's the ground. So it snows and it just leaves a little blanket, okay, you got a layer of snow, and it freezes because it's cold there all year. And then it snows again, and it snows again, and it snows again, and then you have all these layers, and it's getting really heavy on the bottom. So they just crush into ice. They just turn into ice, all right? And it snows more, it turns into ice more, and there's so much ice going on down here. And basically, the snow has, because snow is fluffy, it has pockets of air in them, and as it crushes, there are pockets of what the atmosphere was like when that snow fell. So here's some air bubbles. I know this is a rough rendition, but you're with me, right? You can count back the layers of frozen snow literally by year, like tree rings, to see how old that ice core is. Ice cores can be miles long. I love it so much. They get these huge things and they drill into the Arctic until they reach the ground. It's magnificent. Anyway, here's an ice core which has a little stripe of volcanic ash in it. I'm just trying to drive home the point that this isn't like some weird pseudoscience where they're deducing how much carbon is in the air. They have physical pockets of air in there and pieces of ash. There's some pollen in there. and they can measure how much there was and approximate how long ago it was. Everyone with me? Okay, cool. Thank you. Here's a really happy NASA scientist drilling an ice core. I just wanted to include that. I think she's really fun. I trust her. Okay, so proving the second part of my thesis. This is great. Look at that. I'm like halfway done. Killing it.
What can we do about climate change?
Oh my gosh, Kyle, you're participating. Thanks. Okay, so climate change's worst effects can be avoided through a combination of reducing greenhouse gas emissions and carbon sequestration, as I pointed out earlier. I'm pulling that thesis through my presentation. So here are where my emissions are, not my emissions, where our emissions come from. It's the world. We're going to start with some innovation to reduce emissions in the electrical generation field. So you know the three usual subjects: wind, hydroelectric, and solar power. We're not going to talk about the ugly stepsister geothermal because I do not trust her. We can reduce greenhouse gas emissions by switching to a combination of these and other energy methods. I want to focus on solar real quick though, because I think solar energy gets a bad rep. Everyone's like, look, you can't generate solar power when it's shady, and that's shady. That's a bad pun. You. And the technology for storing solar energy, they feel like isn't quite there, but like the innovation in this field, like every month something new comes out, and I'm going to give you some really cool examples. So this is a 1/2 inch square of solar fabric. There are 6 solar cells in this piece of fabric, and this technology was developed by these two ladies who are Trisha Andrew and Marianne Fairbanks. They're trying to find ways to weave solar panels into fabric, but I think weave is a like sort of a misnomer because they're basically coating the fabric with 4 different layers of polymers. So the applications for this that are already happening are like stadium covers, and they're thinking of like putting it in clothes. But what I think are the coolest possibilities are coating like virtually any surface with these polymers, so you can turn anything into a solar panel. Mind blown. This is a picture of secretive startup Heliogen, which has developed a way for this array of mirrors to reach temperatures of above 1,000 degrees Celsius, which is high enough to create cement or steel or glass. This sort of like sector of the economy and of production has not been touched by solar energy before. So it is now. These mirrors also, by the way, there's like AI that positions them to sort of angle the sunlight into the most productive spot to reach the highest temperatures. Besides breakthroughs in the solar energy department, we also have some news in the nuclear department. But it's old news, so we're just going to move on. I'm just kidding. Not about it being old news, though. It has existed since the 1950s. Liquid fluoride thorium reactors are powered by thorium, here, as opposed to uranium. It just has 2 less protons. It's very interesting. Thorium is way more plentiful than uranium, like it's as common as dirt. And thorium is less harmful to humans than uranium because it emits alpha particles instead of gamma particles. Can you verify those are less harmful to humans?
Yes.
Thank you. Thank you, Coach Blackston. Uranium powers power reactors, which are PWR, pressurized water reactors. So thorium is more efficient than uranium in nuclear power. It just takes way less thorium to produce the same amount of energy, and its waste is only toxic for like 300 years as opposed to thousands of years, like tens of thousands of years. So why aren't we using these? There are 2 reasons. The US government in the 50s was like, we want to make nuclear-powered submarines, and the coolant in power reactors is water, and submarines are surrounded by water, so that makes sense. I'm with them there, that makes sense. But also because the waste from power reactors can be used in nuclear weapons, and the waste in lifter reactors really can't, and this was in the height of the Cold War. But we don't want to destroy the world. So why are we still using power reactors? These create more energy and we wouldn't have to worry about all this nuclear waste piling up for so long, just 3 centuries. That's not long. All right, we also have some innovation in the manufacturing department. This here is a little orb which is made out of like seaweed gel, and inside it is water. It's from a company called Notpla that's working on sustainable packaging solutions. So this is in the UK, and they're like little sachets, they call them, are in like takeout containers and stuff for sauces. They're working on making like cardboard takeout containers that are lined with like this seaweed-based plastic instead of plastic. This is just one example of plant-based plastics packaging. Packaging is going to head towards these plant-based plastics in the future. There are hundreds of examples of this. I see them all the time. You can make plastic out of bananas and corn and like anything, and you can make them to be waterproof or to biodegrade in a number of weeks. It's so amazing. Anyway, lots of options. As for the agricultural sector, agricultural emissions come from farming, ranching, forestry, and deforestation. So it kind of overlaps with the carbon sequestration bit. But this is a picture of the Murray Valley, which is an ancient Incan agricultural experimentation site. It's super cool. On each of these like level rings, they found different like remains of plants. So the best guess that archaeologists have is that the ancient Incans experimented with how high, like in what altitudes different plants grew and like what plants grew best together. And so the past of agricultural science is the future of agricultural science. The best, like scientists and farmers are using technology to come up with ways to plant crops through trees, like plow around trees, and also to like plant nutrient complementary plants, which is an old technique. You know, you plant like corn and you plant wheat as like to restore like nitrogen to the soil or something. Verified. All right, carbon sequestration. This is just, again, it's like a carbon sink. You're just taking carbon dioxide out of the atmosphere. There are a few different methods for this. So we have carbon capture and storage technology and bioenergy and carbon capture and storage technology. And I'll get to that in a second. We also have natural sequestration methods. So there's afforestation, which is basically what like a lot of governments or companies are talking about when they say that we like plant trees. They plant the same species of tree in a row. And the problem with that is that they're not really rebuilding the like natural environment the way they left it. And also planting trees in a row is really convenient for lumber companies that are like, gee, thanks, we'll just cut them down in a row now. We don't have to move around in a regular pattern. Also, monoculture leads to disease. All of those trees can be wiped out in one fell swoop. So, afforestation is kind of not the thing. Rewilding, though, it's really dope. In the UK, they've been rebuilding wetlands around the coast. They have a lot of successful rewilding programs, but their coastal rewilding program is, I think, the coolest because wetlands sequester more carbon than any other natural habitat on Earth. So basically, you just plant native plants or trees and leave it alone. And I know this just sounds like a tree hugger conservation thing, like, gosh, leave the natural habitat alone. But seriously, it takes more carbon out of the atmosphere. There's also the Great Green Wall Project in Africa, which is a project to line the southern border of the Saharan Desert with trees and grass to combat desertification. And it's really helped alleviate conflict in the area because like they're fighting over resources, and now there's resources. Like they make grass banks so that local ranchers can let their animals graze in there, so there's always grass available for them. Now on to carbon capture and storage technology and BECCS. We'll get there in a second. I'm going to go here for a picture. This is a picture of the world's first carbon capture and storage facility. What these fans do is literally filter carbon dioxide out of the atmosphere and then store it underground. This carbon dioxide can be used in cement, soda, carbon fiber, and maybe even those carbon nanotubes that Jack was talking about a little while ago. I don't know, Jack, maybe you could look into that. It'd be cool. Bioenergy and carbon capture and storage technology is basically when they burn biomass or biofuel and then just immediately capture those emissions and the carbon dioxide and do the same thing with them. So the International Panel on Climate Change finds that all of the pathways that reach the Paris Climate Agreement goal of only 1.5 degrees Celsius warming since pre-industrial levels require carbon dioxide removal in some form. So we have options as to how much like CCS technology we want to use versus how much rewilding we want to use, but we kind of have to choose one of those or both of those. You have to choose an option. So why is this all so hard to believe? I think that there are two reasons. First of all is press coverage. So this is an article from Fox News that implicated that we were heading towards an ice age soon instead of that the climate was warming. The study that they cited is from this guy, Malte Jansen, a professor from the University of Chicago. But after 30 seconds of Googling, I found this. You'll see that he has at the top of his website this notification that, ooh, look, I can use the laser pointer. This article on Fox News, among others, have been misrepresenting his study's results. To Fox News' credit, they did post this disclaimer later on the bottom of the article, but frankly the damage was already done because most people don't go back, even if they don't just read the headline, they don't go back through the article and read it again and go all the way to the bottom. So the people who are misinformed by this article are most likely still misinformed. And it's not just like Fox News is doing this. All the news outlets are publishing things without verifying if they're true, apparently. Here are some really whack articles. These are all insane, but it really isn't just total dishonesty. Also, there's also just kind of misrepresentation in like words. This is a response posted by NASA about how some people say that scientists don't agree on Earth's temperature changes. The difference is like 0.2 degrees Celsius. That's just not that much disagreement, you know? So a headline can say that like, oh, scientists say that oh my gosh, we're gonna move on. The other reason is because it's just really hard to comprehend this sort of existential threat. I think you can fight or flee, and we can't flee Earth at this point. We see it as too overwhelming a problem to fight by ourselves, and so we all freeze and we just sort of ignore it and we go about our daily lives. But I've just told you that there are things we can do. So what have we learned? Is this about saving the planet? No! This is about saving humanity. Earth is going to be fine, okay? Earth is it's getting a fever to get rid of the virus of man, all right? We don't want that, though. This seems like a pain now, but this is going to feel deadly later. It's just we're procrastinating infrastructure changes. All right, thank you. These are my sources.